Hello, hi everyone. Welcome to the Student the Brand. Now we are discussing light reflection and refraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Okay. When light incident on the surface, it reflect back. When light ray incident on the surface, it reflect back. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called a reflection of light. Okay. Incident ray, reflected ray, normal line, angle of incidence, everything we'll discuss now. Light reflection and refraction. Light reflection, right? Reflection and refraction. Refraction. Okay. Here you can observe. Here you can observe light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Here you can see. I'm taking this incident ray. I'm taking this a plane mirror. This is a plane mirror. The light ray which is incidenting on the surface is called incident ray. This is incident ray. And the light ray which is reflecting back is called reflected ray. Reflected ray. Okay. Reflected ray. And the light ray which is perpendicular to the plane surface, that is called normal line. Actually, that dotted line is not existed. For our understanding sake, we are drawing the dotted line. Okay. The angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, this is the angle of incidence and this is the angle of reflection, and the light ray which is undeviated. Without any deviation, the light ray is passing, or initial direction of the incident ray is called undeviated line. That is undeviated line. You can observe here, this is the undeviated line. The angle between reflected ray and deviated line is called angle of deviation. Angle between reflected ray and undeviated line is called angle of deviation. Is called angle of deviation. Incident ray, reflected ray, normal line, and the undeviated line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay. And coming to loss of reflection. Loss of reflection. Okay. Loss of reflection. Let's discuss about loss of reflection. Loss of reflection. Okay. Loss of reflection. Loss of reflection. Here you can observe incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Point number 1. Angle of incident is equal to angle of reflection. Okay. Point number 1. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Okay. And one more thing. You have to understand one thing here. Completely in a circle, the angle is 360 degrees. Half of the circle is 180 degrees. Half of the circle is 180 degrees. Yes or no? Here also, this is the half of the circle. I am taking this angle. How much? 180 degrees. Half of the circle is how much? 180 degrees. Yes or no? 180 degrees. Correct. Okay. So only physics. So chemistry will see later. So only physics we are teaching. Okay. So thank you so much. I'll consider that point. I'll consider that point. Okay. So continue that. And here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So you know from laws of reflection, angle of incident is equal to angle of reflection. From laws of reflection, angle of incident is equal to angle of reflection. Yes or no? Yes. So that we can write angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. Yes or no? So if you are taking in the place of angle of incidence, if I substitute angle of reflection in the place of angle of incidence, if I substitute angle of reflection, then I will get angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation formula. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Right? Yes. So that is about angle of incidence, angle of reflection and angle of deviation. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay. And laws of reflection. What are the laws of reflection? Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Point number 1. Point number 2. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. And coming to angle of deviation, angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay. So now we will discuss about regular reflection and irregular reflection. Are you all ready for regular reflection and irregular reflection? So coming to regular reflection and irregular reflection. Incident light rays are parallel, then reflected light rays are also parallel to each other. Incident light rays are parallel, then reflected light rays are also parallel to each other. That type of reflection is called regular reflection. Regular reflection. Okay, regular reflection. So, hello everyone, welcome to the Student Brand. Please do like, share, and subscribe to Student Brand. If you like the content, if you like the channel, if you like my explanation, do like, share, and subscribe to Student Brand. Share to your friends, ask your friends to join to the class. Let them know. Here, physics class is going on. Siva sir is teaching in the Student Brand channel. Right? Yes. So, coming to regular reflection. Regular reflection, regular reflection, regular reflection. So here you can observe, So I'm taking this plane mirror. This is a plane mirror, right? Okay. So one side is coated, another side is reflecting surface. One side is coated, another side is reflecting surface. Okay. So incident light rays are parallel to each other. So I'm taking these are the incident light rays. 1, 2, 3, and 4. Incident parallel beam. Incident parallel beam. Then reflected beam also parallel. Okay. Reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection. So incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So here you can observe. Incident light rays are parallel. Reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. These light rays will move in different directions. Yes or no? Incident light rays are parallel and reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. And here incident light rays are parallel, then reflector light rays are also parallel to each other. The type of reflection is called regular reflection. Regular reflection and irregular reflection. Okay. So now we will discuss about object and image. Let's start. Object and image. Object and image. Okay. Object and image. So I'm taking the plane mirror. One side is reflecting surface, another side is coated, silver coating. Okay. Now you can see here. So I'm taking this the plane mirror. This is the plane mirror, right? Like this. Light rays are coming from infinity. So our light rays are coming from the source. Like this. After reflection, those light rays are meeting at one point. After reflection, light rays are meeting at one point. Okay. So incident light rays are meeting at one. Reflector light rays are meeting at one point. So this is the point where the light rays are meeting. That is a real image. Reflector light rays are meeting. Reflector light rays are meeting. Okay. Yes or no? That image is called real image. The point of intersection of reflector light rays is called real image. Okay. So if you are extending these incident light rays, These are the virtual object. Virtual object. The point of intersection of reflected light rays is known as the real image. The point of intersection of extended incident light rays is known as virtual object. Virtual object. Okay. So now if you are taking one more like this. So this is the object, from here light rays are coming. Okay. So here you can see, if you are extending those reflector light rays, this is the real object. Real object. And here it is a virtual image. Real object and virtual image. Real object and virtual image. Right? So once again, here you can observe. So the point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called real image. The point of intersection of incident light rays is called virtual object. And here the point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. Virtual image. Okay. And from here the light rays are coming. From this point light rays are coming. Yes or no? From this point light rays are coming. That is a real object. That is a real object. If you see the tabular column, so if you see the tabular column, I am drawing the tabular column. So now you can see here, this is the tabular column. Object is real. Object is real. Image is object is real. Image is virtual. Object is virtual. Image is real. Understood or not? I hope it is very clear. Okay. So once again, object is real. Image is virtual. Object is virtual. Image is real. Next one. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So we'll discuss that one. Okay. So now you can see here. So here I am placing here this object A, B. Okay. So if the light ray is passing along the normal line, it retraces its original path. It moves in the same direction. If the light ray is passing along the normal line, it retraces its original path, moves in the same direction. So here I am taking here. Okay, so we are extending here like this. So this is the incident ray, reflected ray, and one more thing here. And here also we are extending this one, and here also we are extending this point. If you are extending those light rays, extended reflector light rays are meeting at one point. So if you are extending this reflector light ray, so A dash and B dash, A dash and B dash. Now You can see object is real, image is virtual. Object is virtual, image is real. Point number 1. Coming to point number 2, object distance is equal to image distance. So this is the object, this is the image, and this is the image. So the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance. Okay. Object distance is equal to image distance. And the next one, height of the object is equal to height of the image. And the fourth one, height of the object is equal to height of the image. And the next one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So m equal to +1. M equal to +1. Okay. And it also shows lateral inversion. It also shows lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be the right side of the image. Okay. So this mirror image is called lateral inversion. This mirror image is called lateral inversion. Right? Yes. Now, next one. Right, next one. Spherical mirror. The mirror which in the form of curved surface is called spherical mirror. The mirror which in the form of curved surface is called spherical mirror. So in spherical mirror there are two types of mirrors, concave mirror and convex mirror. Concave mirror whose reflection takes place inward. Convex mirror whose reflection takes place outward. Yes. Concave mirror is converging in nature, whereas convex mirror is in diverging nature. Okay. Concave mirror is in converging nature, whereas convex mirror is in diverging nature. So due to light effect, so you have to wear the specs. Sorry for it. Okay. I hope it is very clear. Concave mirror is in converging nature, convex mirror is in diverging nature. Understood? Right. Let's discuss the concept. Okay. Concave mirror is in converging nature, convex mirror is in diverging nature. So next, terms related to spherical mirror. Terms related to spherical mirror. Let's discuss. So here I am taking this the concave mirror. It is a part of the imaginary sphere in which it is a part of the sphere. Okay, concave mirror. Let's see. So here, this is a part of the sphere in which this is the center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Okay, so here you can observe. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining of centra curvature and pole is called. The line joining of centra curvature and pole is called principal axis. The line joining of centra curvature and pole is called principal axis. Okay. First point is centra curvature. Second point is pole. Third one is principal axis. The distance between centra curvature and pole is called. The distance between centra curvature and pole is called. The distance between centra curvature and pole is called radius of curvature. Okay, so the distance between centra curvature to pole is called radius of curvature. This is the radius of curvature. Coming to the next one. After reflection, all light rays are meeting at one point on the principal. After reflection, so these are the incident ray. After reflection, those light rays are meeting at one point on the. After reflection, all light rays are meeting at one point on the principal axis. That is called focus. After reflection, all light rays are meeting at one point on the principal axis is called focus. Okay, so this is the focus. The distance between focus to pole is called focal length. Okay, so the distance between focus to pole is called focal length f. The diameter of the reflecting surface, or width of the reflecting surface is called aperture. Okay, so one is center of curvature, pole, radius of curvature, center of curvature, pole, radius of curvature, principal axis, aperture, and focal length. These are the terms related to spherical mirror. Right? Now we will discuss about ray rules of concave mirror. Let's start. Ray rules of concave mirror. Ray rules of concave mirror. Okay, so I am drawing. So concave mirror, converging mirror, pole, focus, center of curvature. Pole, focus, center of curvature. After reflection, light ray passes through focus. After reflection, light ray is passing through focus. Okay, so first ray after reflection passes through focus. Point number 1. Coming to point number 2. Pole, focus, center of curvature. Light ray is passing through focus after reflection, moves towards infinity. So you can see light ray is passing through focus. After reflection, it moves towards infinity. That is the second one. Coming to the third one, light ray is passing through center of curvature. It retraces its original path. So third one. So pole, focus, central curvature, light ray is passing through central curvature. So it retraces its original path. After reflection, it retraces its original path. Okay. So next one is, so fourth one. So pole, focus, central curvature. Light ray is incident at the pole, it reflect back. Light ray is incident at the pole, it reflect back. So like a reflection phenomena. Okay. So now convex mirror. So I'll discuss for convex mirror. Okay, let's start. So I'm taking this a convex mirror. Pole, focus, central curvature. Pole, focus and central curvature. Light ray is coming from infinity, after reflection passes through focus. Light ray is coming from infinity, after reflection passes through focus. So here light ray is coming from infinity, after reflection passes through focus, right? It passes through focus. Second one, light ray is passing through focus. So pole, focus, central curvature. Light ray is passing through focus. After reflection, it moves towards infinity. Light ray is passing through focus. After reflection, it moves towards infinity. And coming to the next one, third one, light ray is passing through central curvature. Pole, focus, central curvature. Light ray is passing through central curvature. It retraces. So it retraces its original path. Light ray is passing through central curvature. It retraces its original path. Okay? Yes. Next one. So light ray is incident at the pole. So you can see. So pole, focus, central curvature. Light ray is incident at the pole, it reflects back. Like a reflection. Understood? So I hope it is very clear. Right? So right from starting, light ray is coming from infinity, after reflection passes through focus. Second one, light ray is passing through focus, after reflection moves towards infinity. And third one, light ray is passing through central curvature, it retraces its original path. And the fourth one, light ray is incident at the pole, it reflects back. So these are the ray rules of concave mirror and convex mirror. Now we will discuss for image formation by concave mirror. Image formation by concave mirror. So if the object is placed at infinity, where image will form? Image will form at focus. What is the nature of the image? Real and inverted and highly diminished. If the object is placed beyond central curvature, where image will form between C and F? What is the nature of the image? Real and inverted and diminished. If the object is placed at C, where image will form at C itself? What is the nature of the image? Real and inverted, and size of the image is same size. If the object is placed between C and F, where image will form? Image will form beyond central curvature. Nature of the image is real and inverted, and size of the image is enlarged. If the object is placed at focus, where image will form? Image will form at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged, because image is formed at infinity. Okay. So next one, object is placed between P and F, where image will form behind the mirror. What is the nature of the image? What is the nature of the image? Virtual, erect. Virtual, erect and enlarged. Virtual, erect and enlarged. Okay. So next one. So concave mirror. Object is at infinity. Image will form at focus. Nature of the image is virtual, erect and highly diminished. And second case, object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual, erect and diminished. These are the two cases for convex mirror. Concave mirror, 6 cases. Convex mirror, 2 cases. Next one, sign conventions. So what are the sign conventions? New Cartesian, sign convention, new Cartesian, sign convention, all a distance measure from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention, all a distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian. Okay, so all measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. Okay, so I hope it is very clear. So this is about sign conventions. And the next one, no, mirror formula. 1 by f equal to 1 by v plus 1 by u. Magnification, height of the image by height of the object, minus v by u. Okay. So that is about concave mirror, image formations and ray rules. So we will discuss about lenses in the next class. So until then, so please do like, share and subscribe to Student Brand. This is our Siva sir from Student Brand. Okay. So if you like the content, if you like the explanation, please do like, share and subscribe to Student Brand. Okay. So inform your friends, ask your friends to join to the class and share this link. Okay, if you like the content, if you like the channel, you can go for a super chat, super thanks and be a member to the channel. Okay, so that's enough. That is about what is that? That is about light rays, light reflection and diffraction. So about mirrors. Coming to the lens. Lens, refraction, the bending of the light ray at the interference of the two medium is called refraction. So if it is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. Okay. So the angle at which the refracted ray passes or gauges along the surface is called critical angle. So if the refracted ray makes more than 90 degrees, it reflects back into the same medium, that is called total internal reflection. If the light ray is passing from denser to rarer. And the next one, light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. So that is about refraction. Still so many points are there related to refraction. So we will discuss in the next class. If you like the content, if you like the channel, if you like the explanation, please do like, share and subscribe. So we'll see you in the next class. Thank you.